Hello and welcome once again to this particular channel. In today's video, we are going to look at the second part of our topic, SARS. At the end of this lesson, we will be able to identify monomial and binomial denominators. We will be able to also rationalize expressions involving SARS. We will also be able to solve an equation containing SARS. Now, let's look at when we talk of monomial and binomial denominators. What do we mean by that? When we consider an expression of the form 1 over square root of a, it has only one term within the denominator. So for that matter, 1 corresponds to mono. So this particular denominator is a monomial denominator. So a denominator with just one term is called a monomial denominator. Whereas we have an expression of the form 1 over a plus square root of b, or it can be 1 over a minus square root of b, or we can have 1 over square root of a plus square root of b, or we can have 1 over square root of a minus square root of b. We can see that they all have two terms within their denominators. The addition sign separates this as a and root of b. The subtraction sign separates this two, the addition sign here, the subtraction sign here. So all these have two terms within their denominators. So for that matter, they are called binomial denominators because they have two terms within their denominators. So a binomial denominator has two terms within the and a monomial denominator has only one term. Let's now look at how to rationalize SARS. Rationalizing SARS here means we have to remove the square root from the SARS. It can either be a numerator we are rationalizing or a denominator we are rationalizing. So rationalizing simple means remove the square root or removing the square root from the term you are rationalizing. So for example, if you are asked to rationalize the following, to rationalize this, first of all, let's look at the I, where we have 1 over root of 3. To rationalize 1 over root of 3, we can see that it is the denominator which contains the SARS, which is root of 3. So we'll have to multiply, or first of all, you look at the denominator. We can see that the denominator is a monomial denominator. So you simply multiply the denominator by the numerator and itself. So this will be equal to 1 over root of 3 multiplied by root of 3 over root of 3. So that when multiplying, we'll have 1 by root of 3 by root of 3. And this gives us 1 by root of 3 gives us root 3. Root of 3 by root of 3 gives us root of 3 squared. And we said that from the properties of SARS, root of 3 or root of any number raised to an exponent 2 becomes the same number. Can you remember that? Or we simply say that the square will cancel the square root, leaving the denominator to be 3. So this will now be root of 3 over 3. We can see that the surd or the denominator doesn't contain any square root again, so we have rationalized the surd. Now let's look at 2 over root of 10. Again, multiply 2 by root of 10 and root of 10 by root of 10, and that gives us 2 root of 10 over root of 10 square. Square goes with square root, leaving 2 root of 10 over 10. But 2 is a factor of 10, so we can simplify. 2 can go into itself 1, so the numerator will be left with root of 10. Then into 10, 5, so the denominator will be left with 5. So this will now be root of 10 over 5 as rationalized and simplified. For Roman number 3, we have 2 over 2 root of 3. First of all, we can see that the denominator here is different from the denominator in example I and II. There is a number standing in front of the root of 3. When we are rationalizing here, we say pick the denominator, multiply by the numerator and itself. This one we say pick the denominator, multiply by the numerator and itself, as here. In this case, we have two options. We can pick the numerator, multiply by the numerator and itself, or we simply pick the term containing the surd alone. So you can either multiply by 2 root of 3 or you pick root of 3. So let's pick root of 3. If you are multiplying by root of 3, then we'll now have 2 multiply or 2 over root of over 2 root of 3 multiply by root of 3 over root of 3. That is, we are picking just the term containing the surd here. So this will give us 2 by root of 3, then 2 by root 2 root 3 by root 3, and this will give us 2 root of 3 over 2 multiplied by root of 3 squared. So when we do that, we can simplify. Square here will just cancel the square root, leaving 2 multiplied by 3 down there. And we can see that 2 is here, 2 is there. We can cancel them out. So 2 will cancel 2 here, leaving root 3 on top, and the down will be left with 3. So when we rationalize, we'll have root of 3 over 3. Let's look at the example 4, which is 4 root of 3 over 3 root of 2. How do we rationalize that? In order to rationalize, we can multiply, or we are going to pick the term containing the surd in the denominator, multiply by the top and down. So when we multiply, we'll have 4 root of 3 multiplied by root of 2 over 3 root of 2 multiplied by root of 2. So this will then give us 4 root of 6, because when you are multiplying from the properties of surd, you multiply the terms under the square root sign. So we'll have 3 by 2, that gives us 6. 4 by what is outside here, 1, will give us 4. Then this one, 2, 3, and 2 by root of 2 by root of 2 gives us root of 2 square. Multiply by 3, so root 2 square will cancel square root. When that happens, we'll be left with 4 root of 6 over 3 multiplied by 2. Then we can multiply 3 by 2 gives us 6. So this will be 4 root of 6 over 6. We have a factor which can go into 4 at the same time into 6. And the factor here is 2. So 2 into 4 gives us 2. 2 into 6 gives us 3. So when we simplify, we'll have 2 root of 6 over 3 as the rationalized and simplified form of 4 root of 3 over 3 root of 2. Then for Roman number 5, we have 3 over root of 3 minus 2. The minus sign here shows or indicates that we have two terms within the denominator here. So in other words, we have a binomial denominator. When we have a binomial denominator, what we'll do is first of all look for the conjugate of root of 3 minus 2, that is the denominator. And looking for the conjugate simply means if the sign is negative, change it to positive to get its conjugate. If it is positive, we change it to negative to get the conjugate. So when you look at this one, the conjugate of root of 3 minus 2 will be root of 3 plus 2. Just change the negative sign to positive sign. When you do that, now multiply the top and the down by the conjugate. So this will now be equal to 3 over root of 3 minus 2 multiplied by root of 3 plus 2. That's the conjugate over root of 3 plus 2. Now this will be multiplied by that. This will also be multiplied by that. So doing that, we'll have this. We are multiplying. So multiplying it 3 by root of 3. We have that. Then 3 by 2 gives us what? 6, right? Then when you come to the denominator, when you look at the denominator, we have root of 3 minus 2 and root of 3 plus 2. See that the signs are different, but they are the same. The terms are the same. So when we have that, in expanding or in factorizing this one, we apply what we call difference of two squares, which we have here. Assuming you have a squared minus b squared, then it will be equal to a minus b multiplied by a plus b. And see that this particular expression is written in this form. So we can send it to this form. So sending it to this form, our a in this case becomes root of 3. Our b in this case becomes 2. So we can write this one as root of 3 squared minus the b, which is 2 squared. So when we do that, this will now be given as that. So substituting, we have this over square root of 3 squared minus 2 squared. Simplifying or expanding the top, we have 3 by root 3, then 3 by 2, 6. Then this square will cancel square root, leaving 3. 2 squared is what? 4. So 3 minus 4 down there. So this will now give us 3 root of 3 plus 6 over negative 1. And when it happens that way, any number dividing by 1 is the same number. And any number dividing by negative 1 is negative that number. So once we say negative that number, the negative sign here is going to affect this term and this term. And that gives us negative 3 root of 3 minus 6 as rationalized, and simplified. Let's look at Vin I. 1 given 1 over 1 minus root of 3. If you are going to rationalize, we say first of all, since we have a binomial denominator, we have to find the conjugate of that. So conjugate of 1 minus root of 3 will be 1 plus root of 3. Now multiply the conjugate by the top and the down, so that we'll have 1 over root of 3, or 1 multiplied by 1 over root of 3, then 1 minus root of 3 by 1 plus root of 3. That is, we are multiplying the top and the down by the conjugate. We'll do that. First expand the top so that you have 1 plus root of 3. Then the down, we demonstrated with difference of 2 squares. This will be 1 squared minus square root of 3 squared. So we'll have 1 squared minus root of 3 squared. And simplifying the down, 1 squared still gives us 1. Then root of 3 squared, the square will cancel the square root, leaving 3. So we'll have minus 3. And 1 minus 3 is negative 2. So we'll have 1 plus root of 3 over negative 2. Or we can write it as negative 1 plus root of 3 all over 2. And that is the rationalized form of 1 over 1 minus root of 3. We can also look at the example 7. When I. We have 3 root of 2 over 4 root of 2 plus root of 3. Rationalizing this, we have to look for the conjugate of the denominator. And the conjugate of the denominator will be 4 root of 2 minus root of 3. So multiplying the numerator and the denominator by the conjugate, we'll have root of 3 root of 2 over 4 root of 2 plus 3 equal to, so have 3 root of 2 multiplied by the conjugate, then 4 root of 2 plus root of 3 multiplied by the conjugate here. Now let's expand. Expanding, we'll have 12 multiplied by 2 minus 3 root of 6, because 3 will be multiplied by 4 here. That gives us 12. And we know that root of 2 by root of 2 gives us root of 2 squared. And the square will just go with the square root, leaving 2. That is why we have 2 here. So it will be 12 by 2 minus 3 by 1 gives us 3. 2 by 3 gives us 6. That gives us 3 root of 6. Over 4 will be multiplied by 4 here. And that gives us, or we say 4 root of 2 by 4 root of 2 is the same as 4 root of 2 squared minus root of 3 squared, applying difference of 2 squares. So simplifying, the numerator will now be 24 minus 3 root of 6. Then this one will have the square will affect this one, both the root of 2 and the 4. So 4 squared gives us 16. Root of 2 squared, the square will just go with the square root, leaving 2. Minus square will go with the square root, leaving 3. The denominator will now be 32, because 16 by 2 gives us 32. So minus 3. And 32 minus 3 gives us 29. So simplifying, we'll have 24 minus 3 root of 6 all over 29. Then for example 8, we have root of 2 plus 1 over root of 2 minus 1. Both the numerator and the denominator in this particular example are having 2 terms. That is, they are all binomials. So what we'll do is, we again look for the conjugate of the denominator and see that the conjugate of the denominator will be the same as the numerator. Can you see that? Yes. So if that happens, let's multiply the top and the down by the conjugate of the denominator. So this is what we get. Now, if we have that, let's expand. Expanding, we know we are going to pick root of 2 by root of 2, then root of 2 by 1. After that, we'll pick 1 by root of 2, 1 by 1. So when we do that, we'll have this root of 2 by the whole second bracket plus 1 by the second bracket. And that's okay. And the denominator, we apply our difference of 2 squares. So we'll have root of 2 squared minus 1 squared. When this happens, let's expand this. Square root of 2 by root of 2, we can say this is root of 2 squared, or we say root of 4. So simplify, we'll have root of 4 plus 2 root of 2 by 1 will give us root of 2, plus 1 by root of 2 will give us root of 2, 1 by 1 will give us 1, all over square root of 2 squared minus 1 squared. Simplifying, this and that are alike. Square root of 2, 4 rather, gives us 2, plus this one gives us 3. That is what we have here. Then 1 plus 1 gives us 2 root of 2. Square goes with square root, leaving 2. 1 squared is 1. So simplify. The 2 minus 1 gives us 1. And we said any number dividing or any term dividing by 1 is the same term. So that gives us 3 plus 2 root of 2. Let's solve equations containing surds. For this particular aspect of surds, we are going to look at the given equation, which sometimes involve variables, and we are asked to find the variables. And to find the variables, you have to simplify. Sometimes you have to simplify. So without talking much, let's look at examples. If you are asked to solve I, you can also have this. If you are asked to solve this, how do we do that? Let's look at the first example, which is root of 8 plus root of 32 equal to r root of 2. When you look at the right hand side of this particular equation, you can see that the least radicand is 2. You look at the radicand, which is 2 here, the least radicand here 2. Can we divide the least radicand by 32 and get a perfect square? Or can we divide it by 8 and get a perfect square? That is the first question you need to ask yourself. If the answer is yes, then you have simplified your left hand side. So let's see. When we divide 8 by 2, you see that we'll get 4. So 4 is the perfect square in 8. So simplifying, we'll have root of 8 will be the same as 4 root of 4 by root of 2. Can you remember that? So if it is root of 4 by root of 2, root of 4 is what? 2 by root 2. So that gives us 2 root of 2. Then 32 divided by 2 gives us 16. Square root of 16 by square root of 2 gives you square root of 32. The square root of 16 is 4. So simplifying square root of 32, we get 4 root of 2. So we are going to write the simplified form. So root of 8 will now be 2 root of 2. Root of 32 will now be 4 root of 2. and this should be r root of 2. You should know, you have seen that, or you know how to simplify them. Now if you have this, look at the radicals within the Surds. You see that the radicand here is 2, radicand here is 2, radicand here is 2. They are the same. So if they are the same, we can add and equate. So the left hand side, adding them, we just pick one of the square root sign, then we add the terms in front of the square root sign. So we have 2 plus 4, then we pick root of 2. It should be equal to r root of 2. And 2 plus 4 gives us 6 root of 2, then equal to r root of 2. Since the radicands are the same, that means the terms in front should also be the same. So if they should be the same, that means r will be equal to 6. So therefore r is equal to 6. This is how we solve equations containing Surds. So let's look at the example 2. For the example 2, we have square root of x plus 2 equal 3. The left hand side of the equation contains square root. So to remove the square root, we have to square both sides. This is how we remove the square root. So squaring both sides, we'll have square root of x plus 2 squared equal to 3 squared. So square here will cancel square root. Then we have 3 squared, and 3 squared gives us what? 9. So if 3 squared is 9, then we'll have x plus 2 equal to 9. Grouping your like terms, we'll have x equal 9 minus 2, and 9 minus 2 is what? 7. So that means x is equal to 7. Let's look at example 3 on the rationalization of Surds, which is 3 root of 24 minus 48 square root of 48 equal to u root of 6 minus vn root of 3. So again, when you look at that, on your right hand side, we have root of 6, root of 3, the radicands 3 and 6. So you look at this one, 6. If I pick 6, which of these radicands will I divide 6 with or by and get a perfect square? So you see that when we divide 6 by 24, we get a perfect square, which is 4. That is 4 by 6 gives us 24. Then we'll pick 3, divide by 48, we'll get a perfect square, 16. That is square root of 16 by 3 gives us 48. So simplifying, we'll have square 3 by square root of 4 by root of 6, that is the 24. Then the 48 will be square root of 16 by 3, which is equal to u root of 6 minus v root of 3. So this one, separating the terms within the brackets, we have square root of 4 gives us 2 rather. 2 by 3, 6. Then multiply by root 6, then you get 6 root of 6. So this one, when we simplify, gives you 6 root of 6. Then square root of 16 gives you 4 by root of 3. So we get 4 root of 3 equal u root of 6 minus v root of 3. The left hand side, or when you compare them, root 6 here, root 6 there. So in front of the square root sign, we have u. In front here, we have 6. That means u is equal to 6. Then this one, in front of root of 3, we have vn. In front of root of 3, we have 4. That means vn will be equal to 4. And we have rationalized. we have found the values of u and fin. Then for Roman number 4, if you are asked to find the value of 3 plus root of 3 multiplied by 2 plus root of 3 in a form a plus b root of c, we are going to expand such that it will be in this form. So expanding, we pick 3 multiplied by the second bracket. After that, we pick root of 3 multiplied by the second bracket. So doing that, this is what we get. So have 3 multiplied by 2 root of 3 plus root of 3 multiplied by 2 root of 3, which is a equal to a plus b root of c. Doing that, 3 by 2 gives us 6 plus 3 by root of 3 gives us 3 root of 3 plus this and that will give us 2 root of 3 plus 9 equal to a plus b root of c. We can group like terms. This and that are alike. So 3 plus 2 gives us 5. And root of 9 gives us 3. So this would be 9, 3 here plus 6 gives us 9. So have 9, or simplifying, that is what we get. So 6 plus 3 gives us 9. So 3 plus 2 gives us 5. Root of 3 equal to a plus b root of c. When you compare, you see that the left hand side is now in the same form of the right hand side. So comparing them, what stands alone becomes your a. In front of square root of your square root becomes your b. Then under the square root becomes your c. So a will be equal to 9, b will be 5, and c will be 3. Thank you very much for watching. Please take your time, go through it from the beginning to the end. If any question, comment, and please share and subscribe to my channel for the next part containing SARS, the next part on SARS. In the next part on SARS, we are going to look at likely questions, or we are going to discuss past questions concerning SARS. Thank you very much, and bye for now.